Now we are starting to summarize data, okay, and even in summary, when you summarize data, there are reasons for choosing certain things, okay. So there are two kinds of summary you want to give, okay. So let us say if I throw a die, okay, let us take not even if I throw a die, what is the mean value, average, mean value, typically what do you think is like mean value? How did you arrive? See 1 to 6, right, I do not even need to know some rocket science or some probability etc., which I have not introduced to know this. 1 to 6 is the output, all are equally likely, very simple, all are equally likely. So then the center point should be somewhere around 3, I do not even want the exact number, somewhere around 3. 1 to 6 if I arrange in ascending order, what will be the median? What will be the median? 3.5, right. Now that itself should tell you the look, it is what it is, I mean center value is 3.5. Now just because it is 3.5, can I next time expect the average value to occur? If I throw a die, next point will it be 3.5, around 3? So I throw a die, I know what is the average value, it should be around 3.5. Will I get 3 or will I get 4 every time? No, right, it is equally likely. So when I want to summarize the data, how do you want to summarize? Why do you give mean and something else or center value and something else? So what is the idea behind summarizing the data? Let us understand this. What is the idea behind if you want to summarize the data, if you want to give some information about the data, what all you want to give? What is it you want to give actually? You have collected data, you want to explain it to somebody, a simple number that can be used by them to infer or understand the distributions etc. of the data. So what is it you want to give? What are the numbers that will become useful? Minimum and maximum, okay. Why average? Why min max? Okay, range can be, okay. Then what else? So what I mean, what is the person going to, if a person is going to look at the data, what is he wanting to do? Is he wanting to just look at the data? What is his thought process? Suppose you are presenting the data to me. So let us say you collected a data of a device, right, of a device that was running for let us say 5 hours, you are collecting the let us say you are collecting temperature data, okay, or let us say as I said I am collecting force values from the foot or many other cases, right. You are presenting it to me, what will I be looking at, what will I be looking for, or even if I present to you, what will you be looking for? Suppose the data is given to you, what will you be looking for? If you are if you take non-biomedical, let us take a simple example, I give you stock prices, money, people should know what to look for, right. So suppose I give you stock prices of let us say SBI bank, okay, I give you for 1 month, I have looked at the entire 1 month data, I gave you the mean value, I gave you the range value. What are you typically looking for? What are you typically looking for from me? Is that all you are looking for? Why will I be looking for SBI stock prices? To make, is there some predictability that I can immediately make out? Is there some pattern? The inherent interest and also the correctness, right. Suppose in this kind of data, suppose you have collected the temperature using a sensor, newly developed sensor, what will I be looking for? If I am operating on if I have used it on a normal person, you know the range, then your mean should be close, and then what should be the variability in the data? Should be lower, variability cannot be higher. It is not just the center value which is important, it is also the variability which becomes important. In throwing a die, if you give me the center value is 3.5, oh, so you have collected some, let us say somebody is throwing a die, you have collected this die data for let us say 10 days, you have a huge set of data and then you simply give me 3.5 is the mean. Now what is the purpose? If I want to predict, then I will say, oh, look at this data, next time also it will be somewhere close to 3, which is wrong. You have to give me variability. So this summarizing the data itself not only understand the data, but also inherently provides information about predicting. Okay. So our objectives, when you look at statistics, our objectives, people do it, the objectives are objectives can be different. One is interested in just knowing the spread in the data, is it closer like that new sensor developed, or one is interested in predicting what the future will be. Many of us will be, many a times you will be interested in predicting, or somebody will be interested in, is there a pattern in the data, right, that pattern can be used for something else, right. So when you want to present, you have to present numbers which are meaningful and serves these purposes, and that is why typically you want to summarize using not only the central values, the values which give information about the center of the distribution, but also about the variations. And not only that, this measures of central tendency, what we call the centers, that should have some meaning to predictability, that should have some meaning to prediction. So suppose this is, I think I have given an example somewhere, suppose I have these numbers, what will be my next number if you want to predict? What is the next number for prediction? I have not given that there is any pattern, I did not tell you that all are equally likely. So what is the next number? Why? He says average. Why? So why average becomes the predicted value? Why is that?
That becomes the most likely.
How? Why? Prove it. So our central tendency, whatever measures we give should also cater to predictions, should also give information about the data, should also cater to predictions. We all know what are the measures of, I will come back to this question. So we all know about what is the central tendency, measures of central tendency, you would have learned it long, that is not the point I want to make, mode, median, mean, right. Now what is, so let me take specifically what is the interest with regard to mean. Okay, we will specifically address mean first. Okay, what is our interest in mean? Let us go back to this question. I am taking mean as one of the measures to an important data point or an important point, not a data point, an important metric or score to be displayed when I am summarizing the data, right. I want to summarize the data and mean is one of the key points, right. Why is it so? Suppose you have a data like this, right. I want to, so in my prediction what do I want to do? I do not know, let us say I want this as some xi to be predicted, right. This is x and xi is unknown, I equals to 5 is unknown, right. How do I predict xi? What do you want when you predict? What is your objective? When you predict something, what is your objective? Should be close to all other values, huh? Close to the central value. I am predicting tomorrow, you have never looked at traded or you have never looked at money wise, huh? So next moment I want to predict stock price, What will be my objective? Predict the truth. Come on, when I say predict, I will be predicting something close to the truth. Why other values? Why average? Next moment if stock price is 100, if I have predicted 100 and I have bet on it, I am making money, right? Otherwise I am not. Look at everywhere, if I am developing a drug and predicting this will be the the antibodies developed, or this is the kind of impact I am interested in. When I predict, I am interested in predicting closer to the truth. In fact, if I predict exactly equal to the truth, I will be the most happiest. Agreed? So, what am I want to predict? I want to make sure my error, let us say xi minus xi hat should be what? Ideally it should be what? 0. So, this should be minimal, right. So, now, so I am going to minimize, but the problem with this is what? Should I minimize error? Error can be both negative and positive, right. Negative error means if negative infinity is lower or 0 is lower. So, you cannot minimize error. If you minimize error, your answer will come to negative infinity. You will be very far from the truth on the negative side, does not make any sense. So, one way to do is what? An absolute error. The other way to do is what? Squared error. Why squared error is easy? I have assumed squared error is easy, but I am asking you why squared error is preferred. You all know squared error is many times preferred. Why squared error is preferred? Huh? What? Convergence. Why? So, if how do you find a minima or a maxima? I want to minimize it. How do you find a minima or a maxima? Differentiating, right. That is one way, that is not the only way. There are matrix algebra ways to find it out very easily, okay. But let us put it, you want to find out the minima. How do I do the minima? Differencing. So, when differencing, what happens at the minima or maxima point? Either you take a bowl or inverted bowl, at the peak your slope is 0. So, you differentiate and equate it to 0. For a minima, the second differential should be greater than 0, because it is a bowl, either sides of the bowl, the point, you go in this direction or this direction, slope is increasing and positive. Whereas, if you keep like this, the top point, the slope is 0, and if you go in this direction or in this direction, the slope is only negative, reducing. So, for a minima, your second derivative should be greater than 0 and your first derivative should be equal to 0. It is a very simple, and you can extend it to, if your second derivative is 0, you can go to fourth derivative. If your fourth derivative is 0, you can go to your sixth derivative, etc. So, even order derivative should be greater than 0, odd order should be equal to 0 for a minima. For a maxima, even order should be less than 0, odd order should be equal to 0. Does it make sense? Suppose if I tell you y equal to x power 4, where is the minima? Y equal to x power 4, where is the minima? 0 is the minima, but if you differentiate, first derivative will go to 0, second derivative will also go to 0, third derivative will also go to 0, fourth derivative will be greater than 0, which will be 4, fourth derivative will be something 4 into 3 into 2, 24, fourth derivative will be greater than 0. So, odd order and even order, you have to think of it that way. It is easy to explain first and second order, but third order onwards it becomes very difficult to explain, right. Third order is curvature, so it has its own meaning. right. So, but odd order derivative should be equal to 0, even order should be greater than 0 for a minima. So, invariably you are differencing. Now, the problem with absolute function is it becomes difficult to differentiate. So, it is a continuous function, absolute is a continuous function, but it is not differentiable at x equal to 0. You are approaching from 0 minus and the other side you are taking off from 0 plus. So, there is a discontinuity at 0. So, you do not prefer what I call absolute error, at least earlier days. Today absolute error is highly preferred compared to squared error. So, now I have the squared error minimization. Okay. And of course, you are having what? So many data points. So, you do not want to minimize some squared error. So, you will have, if you are having many predictions, what do? You minimize the sum squared error, okay, and you do not want to minimize the sum squared error, you want to minimize mean squared error, right. You add minimizing the squared error, then what did I say? If you are predicting over long horizon using past data, you will not have one error, you will have many errors, which is mean squared error, sum squared error, and you do not want to just minimize sum, you divide it by a constant, so that it becomes mean squared error. So, this is nothing but minimizing your mean squared. So, now how do I minimize this? Differentiate respect to what? Let us call this as j. What should I do? Minimize j with regard to what? X, dou j by dou x, sure. X is data, what is unknown? How will you minimize this? By finding out x or x hat? X is known to you, only x hat is unknown. So, you minimize with regard to what will I get? Differentiate, what will I get? 2 times xi minus into minus 1 equals to 0. So, what will happen? And then of course, O over n is there. So, then 2 over n, 2 over n summation xi equals to 2 over n summation xi hat. Now, we can cancel this 1 over n, 1 over n, right. What is summation of xi? What is summation of xi? Summation of xi is the data summation. What is summation of xi hat? N times xi hat. Xi hat is a single number. Remember, you are interested in prediction only one value. So, xi hat is a single number, whereas xi is the data. So, what will happen? 1 over n summation xi equals to 1 over n xi hat. So, what is xi hat? Okay. So, what is your importance of mean? Mean also is the best prediction when you are minimizing the mean squared error. When you want to minimize the mean squared error, mean is the value. Now, what am I going to ask is the following: median, what is its connection to prediction? We do not give numbers which does not serve purposes like prediction, which is an important objective. So, what is median? Why do we need median? It is just 50% of data. Is that what? Is that all we know? Median has a much bigger relation or much bigger impact compared to just looking at the 50-50 value. People think median means what? Center point, it serves that purpose. No, median has a higher order importance, exactly like mean. Median is also connected with predictability. Okay, median is also connected with predictability and mode is also connected with predictability, clear. So, mean, median, mode, all the quantitative metrics that we use to represent the data has connection with predictions. Okay. So, mode, when will it become useful? Why do you want mode? When does it become useful? Suppose I am collecting temperature data in this room, will mode be useful or not? Will mode be useful? Why? But will the temperature repeat in the first place? See, I have a 2-digit, let us say I have a 2-digit accurate sensor. How many times will I get 32.32? Does it make sense? You understand my point? You have to interpret it carefully. 32.10, how many times I will get in this room? 32 degrees Celsius, 0.10. Is it even possible? No. So, for continuous data, mode has little reference. As I said, for continuous data, mode has to be interpreted something. So, mode tells that if some number is occurring 1000 times, then it tells that the sensor has failed. Basically, sensor is not doing its job. Why? Only then values can repeat in a continuous case. When will values repeat exactly in a continuous data? With 3 decimal or 2 decimal accuracy, will the sensor give exact value multiple times? Hardly 2-3 times you will get. If you get 100 times, what does it mean? Sensor is gone. The worst case is you will get zeros many times, that indicates that sensor is not working, right. So, mode is not useful when you are talking about continuous. When I said continuous with decimal accuracy, mode becomes very useful when you are talking about discrete data. For a discrete data, is mean becomes useful? Does mean become useful for a discrete data? No. So, why? Suppose I toss a coin, what is the mean value? 0.5. Is it of any use? 0.5, what is 0.5? Tossing a coin, mean value is not, it is qualitative, the sample space is qualitative in the first place, head or tail. So, what is, suppose I collect 10 heads and 10 tails, what does mean tell me? Suppose I collect 20, 30 heads and 10 tails, okay. Still what does it tell me? Mean, does it tell you anything? Anything useful? 30 heads, 10 tails, how will you represent with one number? Mode is 30, head, mode is head and it is repeated 30 times. Then you know that, okay, although the coin is unbiased, it seems that the coin is producing more heads, right. So, mode becomes very important when you are talking about categorical variables. When you are talking about discrete variables, mode becomes very useful. What is repeating the most? What is occurring the most in this case, right. Suppose a movie is rated, not rated, a movie you go and then if you want to give good, bad, ugly kind of category, then if many people give good, so you know that that is how you see the rating, right. See the rating as 4, 5 or whatever, that is mode is what? Very good is a mode. Then you know that this is in general good. You see this, Amazon ratings 10, 9, 5 whatever, you know that which one to look for, mode is what you are looking for. What is that? 10 may be the average, nobody cares. First thing you look at is what? This is categorical. How many people have given this? What is that? You see, that is what presenting data is. So, now how quickly, suppose when I ask my student, when somebody is buying, they go and look at and say, sir, 7,000 reviews, out of which 6,000 are 5. Then I know that if I buy also, most likely I am going to give the rating of 5, that is prediction, okay. That is when mode becomes useful, okay. And then qualitative, see, and then if you talk about this mean values, I am sure everybody knows the formulas, etc. I am not going to give. So, there are two kinds of means, we are only talking about sample mean so far, we have never talked about the population, we are talking about the data which you collect, because you are just summarizing the data. So, summary statistics, variability, we have range, variance, standard deviation, standard error of mean. What is range? We know max minus min. Why is variance important? Spread in the data. You have the center, you want to see how the data is spread around the center. And why center? I have already told you the answer. Center because it is very useful for prediction. Now tell me again, tossing of a coin or throwing of a die, 3.5 means what? First of all, 3.5 is not useful for categorical. Okay. Now for a continuous data, let us say if you are measuring temperature in this room, I give you two answers. I simply tell you, hey, this mean value in this temperature is 25 degrees Celsius. Or you want to maintain this room, you know server rooms, right? Forget this room nobody is interested in maintaining temperature, big deal. Suppose you are in a server room, mean value should be 25 degrees Celsius, that is the specification, they are floating a tender. Now I can also supply for maintaining mean value as 25, how? I will supply some some simple ACs, but my mean value will be 25. But what is of interest? It should be constant, almost constant, and nobody can supply an equipment which will maintain 25 degree exact for all the time, that is impossible. You cannot maintain, whatever you do there will be fluctuations. So what should you say? You understand this example? So you go to this vaccine rooms, everybody say it has to be maintained at -4, impossible to exactly maintain at -4. Why? The moment you open the door, it will not be -4, forget it, that cannot be the case. But what are we trying to do? -4 most of the time, or the fluctuation should be smaller. So now it is not just the mean which becomes important, it is the spread which becomes important. So if you have the mean and the spread to be lower, mean to be a constant, spread to be very low, then mean becomes kind of constant. If I want to maintain at -4, I say the spread is -4 plus or minus 0.1 for so many hours, if you do not disturb it, then that is very good for me. And this is very important. You talk about vaccines, milk today is not, packet milk does not come to you, from directly from manufacturer, it goes to Amul or Avin, and then they have this dairy, they maintain, the milk has to be maintained at -4, 1 degree that side. If they want to, if they maintain at -5, they will be paupers, they will not have anything to, any money at all, because maintaining is very difficult, very costly. Okay. If they want to even maintain at -4.2 degree, they will lose money, they cannot give allowance, hey -4, -4.2 I will be safe, very easy, right? But that -4.2 if they have to maintain, that will cost a huge sum of money. Imagine how many tons of milk is being taken care every day, that is not possible. -3.8, all the milk has to be thrown in drain, it will become bad. -4 it has to be maintained, very strict. Okay. That is the kind of, so spread variability should be very small, variability is money, actually not the center, the variability is money, right? You all know gasoline, I will finish this with one example. We all know what is petrol, you know what is the quality of petrol, octane number 98. If I produce at 99, so suppose I am selling that, I will state that I will give it at 98. Now if I produce at 99, what will happen? I am losing a lot of money, If I do at 97, what will happen? I cannot sell it to you, standards. Imagine, variability is key, reducing variability has always been the case. So more than mean, variance becomes actually important, reducing the variability in the data. You will always try reducing the variability in the data when you do biostatistics experiments. Okay. So we all know what is a variance formula, should I tell, or we all know what is variance? X bar the whole square, x minus x bar the whole square divided by n minus 1, we will come to that at a very later point, not now. Okay. And standard deviation is square root of the variance. Why do we do that? You want to maintain the units. When you take a square, the units become squared. So, you want to maintain the same units, then you take a square root, and standard error of the mean is deviation from the mean. So, standard deviation divided by square root of n. We will talk about this later. Standard deviation divided by square root of n. This number we will understand when you learn probability.